One of the things that I like to keep around are what I call worst case scenarios. I'm looking at a Star Trek job here, and you can see that it's about 600 megabytes of data. Of that 600 megabytes, a single curve, the Star Trek curve itself, takes up 500 megabytes. I'm going to drag that Star Trek curve into the tabular editor and scroll down to the bottom here, and you can see there are 507,000 levels. The Star Trek image is 120 floats across, and then all of the original caliper curves for that Star Trek are in there, so that's another 120 floating point values. So you're seeing 240 floating point values across, plus the depth and time and TVD, those curves. So it's a huge curve, and as you can see, I can scroll around in it effortlessly. That 506,000 levels, if I drag them over to the correlation track, get rendered in about a second. So it just rendered that entire curve. When I say render, what I'm talking about is taking all of that raw data and converting it into graphical objects and then displaying it. So it's handled very effortlessly by the VDM framework. Another worst case scenario is soundtrack data. Soundtrack data is sort of the opposite. It's got an enormous number of columns that have to be displayed. I'll show you what I mean. Let me click on this and then go look at that curve group. And these 6 blue curves are called waveforms. And if I look at the number of columns, there are 512 columns across, and there's 6 of them. So that means if I drag that curve into the tabular editor, I'm looking at over 6,000 columns of data. And again, effortless scrolling. You notice how the correlation track, the tabular editor, and the log are all synchronized with each other. And that's extremely useful. I can click on a point here and it takes me to the record number in the tabular editor. Conversely, if I scroll around here, it's highlighting these rows that you see here on the log. So it's a useful feature. Borehole profile is not particularly huge, but it does illustrate how this ability to drag curves around works for all data types. I can take this wireframe and drag it over, or I can take the cross-section plot and drag it over. So it's a useful thing. Also, these are also image curves, and they all share a common property called a gradient. I can switch from this MagTrack Earth to this MagTrack Gray to an Integ Earth, for example. And that applies to any kind of image. If I click on this Star Trek, we may want to see that as a Schlumberger red Earth, for example. I can just change it there. You see it change here, and as soon as it renders, you'll see it change over here as well. Some of the other videos focused on the deliverable gen application, which was the log viewer written in a classroom about 3 years ago to illustrate how easily a new log viewer could be created. And I wanted to show those same worst case scenarios in it, since it was written in 2 hours basically. I can look at these same presentations in a horizontal layout and scroll around easily while in horizontal mode as well. This is a different application that comes from Geoscience, a rock view application. It's sort of a worst case as well, although it's not large data. It has a lot of functions that calculate these different bands of lithology, and then just a everyday log with metadata in it. So this illustrates again that it's not Data Studio or Plot Studio doing the work, it's the VDM architecture underneath, the framework underneath, that's actually doing all of the rendering.